Hi, I'm Andrew Colburn.
I'm Andrew Sanchez.
And we are doing the logarithmic graph function. Now on the graph you can see our function, which is y equals log 2x.
Our graph goes along the y-axis from -3 to +3 and doesn't cross the y-axis at any moment.
Our intercept on the x-axis is 1, 0. But as Andrew said, we have no y-intercept since the equation is 2 to the power of x, so it can't result in a negative, thus crossing over to the other side.
Also because there's no maximum or minimum since the graph is endless and doesn't have the point where the graph stops and changes height.
Our graph has no symmetry whatsoever since it doesn't mirror over the x-axis, y-axis, and doesn't even touch the origin point.
The domain of the graph is 0 and infinity.
Otherwise known as all positive numbers.
And the range is -infinity and infinity.
All real numbers.
Since the x starts at 0 and goes across while this y starts from the very bottom and up and continues.
The end of behavior is f of x to the power is to infinity as x is to 0, and f of x is to -infinity as x is to infinity.
So the inverse of our equation would be 2 to the power of x equals f to the power of -1 x.
A real-world example of this function would be a seashell, because the x-axis of this function never crosses the y-axis, meaning it always has a fraction on the x-axis that it can still do. A seashell loops in a continuous cycle, slowly shortening until you can't see the spiral with your naked eye. Now, just like I just said, it doesn't really go away, it's just very, very small to see from the naked eye.
So the graph of the equation of the graph is important because it can change the shape of the graph, like f of x plus k, which will be played on the screen right now. So as you can see, it's the blue line on the graph right now. The blue line is the movement of k. So let's see what happens when we change the value of k.
Now right now it is going at a random pace, so as it moves up and down the negative from positive 10 to -10, you can see. Now on to the next one, which is kx to the power of x. This one is a little different, but as we see the other graph, it is just moving up the y-axis. That's not changing its slope whatsoever. Now let's go to the other one. Kf to the power of x. Now as you can see, it's a little bit different. It has instead mirrored somewhat, changed its slope over the x-axis instead.
So moving on to the next one, which would be f parentheses k and x. So we would be changing again the value of k. So now let's see what would happen when we change the value. As you can see, it would go up, but then we see that it's mirrored on the other side. So that would be that would happen basically when the value of k is less than 0.
Now finally, f parentheses x plus k. Now as the other one's still going, you can start to see it just mirrors the other side, just like the one before it. Now let's see if we add it instead of just like we did something else. Now as you can see, it's going across the screen, across the y-axis this time, instead of the x-axis, like the first one we showed you. Oh, as you can see, it's going around, and what we learn is, as we said before, it goes up the x-axis, but does not change the slope. I'm Andrew Colburn, and this is our function.
And I'm Andrew Sanchez. Hope to see you later.